Yo, Coach Ray back here with another piecewise video. We're killing it in third period here. Alright, so this piecewise video is going to focus on example 2 in evaluating piecewise functions notes. Okay, so that's what we're looking at right now. Example 2 is just giving you a graph. It's not actually giving you the boundaries or the actual functions. We can't see all of that. We could figure that all out. That's for another set of notes though. Right now we're just looking at the graph, and they're going to ask us to evaluate these things over here to the right. Alright, so f of negative 6. Another way of saying this would be if x is negative 6, what is y? Okay, what is the point on this function where y would be? Okay, another way of saying that, if x is negative 6, where is our function basically? And here's how I want you to look at it. If x is negative 6, here's my x-axis down here. Okay, I'm going to go to where negative 6 is on the x-axis, and the question is, where is my function? My function, or the y value, is right up here. Okay, so I'll mark that. It's right up here at 5. So this point is negative 6, comma 5. That's one of the points on our function. Okay, so the answer to this, when x is negative 6, or f of negative 6 equals positive 5. Okay, no math needed. We're just looking at the graph and making sure you understand how it works. All right, next one, f of negative 3. This is where it gets a little bit complicated. F of negative 3. So I'm on the x-axis. I'm going to negative 3, which is right here. Okay, and I'm going up and saying, where is my function? Uh-oh. My function's kind of in two spots here at negative 3. I hope it's obvious where our function is and where it is not. Okay, our function is right here where the dot is filled in. It is not right here where the dot is open. Okay, we've used open dots already when it came to graphing inequalities on a number line. And what we did is we showed that the answers were everything leading up to this point, even like 0.99999, but not actually that point right there. That's why we leave it open. Okay, so all the answers are here on the red, on the red, on the red, all the way up, all infinity decimals, all the way up to negative 3. But then once we get to negative 3, boom, we jump down here. Okay, so the answer to f of negative 3 is 2, because that's where we're at negative 3. All right, f of negative 1, hopefully kind of simple. I'm going to the x-axis. Negative 1's right here. I'm coming up. My function is right here at 2 again. So when f is negative 1, our function is at 2, or y is 2. All right, f of 1, another crazy one. So I come over here to the x-axis. X is 1. And the question is my function up here, or is my function down here? The answer is down here on the green one because of the filled in dots. Okay, so when x is 1, y is negative 1. All right, last one. When x is 4, so I go over here on the x-axis to 4, where is my function? It's all the way up here. This is at 4, 5, so when f of 4 is equal to 5. Okay, the only other thing I want to say in this video real quick is let's look at this f of negative 1 right here. I'm sorry. Let's look at this f of negative 3. I'm sorry. So when we came over here to negative 3, we were determining, okay, is it up here at the open circle or is it down here at the closed circle? I want to compare that to what we did up top here. Okay, here when I asked you f of 1, what we did was we said is 1 less than 1, and the answer was no, right? So because it doesn't have the equal sign underneath. So this right here would get an open circle just like it did below because it doesn't have the line underneath. Just like with when we graph inequalities on a number line. Okay, because right here 1 is greater than or equal to 1, because it had that equal sign underneath, this would be the filled in dot showing that yes, you use this middle one, not the top one. So that's just on a graph we use dots colored in or open to show that which function do you use because it doesn't fit into both. All right, that's it for this video, and we will knock one more out today.